Hi folks, and welcome to video number 173. This video is on circle theorems 4, 5 and 6, brought to you by me, not Russell Brand. The keywords are the same as in the last video. I'm just going to go for a couple that I didn't particularly explain perfectly, I don't think. A tangent is a line that is on the outside of the circle. We're going to make sure I mention that, that hits the circle at one point and then shoots off again. And then subtended means coming from 2 points, an angle that's been created that's come from 2 points. So if you look at number 6 here, there's an angle, right? This point and this point, the angle is created or subtended from these 2 points, okay? This chord here. All right, there you go. That's a better understanding of those two definitions in this video. I think the rest, explained all right. So, yeah, we need to learn these circle theorems. Now, number 4 is not necessarily a circle theorem. It's an angle fact from way back. But it is useful to know that two radii make an isosceles triangle. So you've got this one here that's been labelled here as an isosceles triangle. But you've also got this one here. If I label that with some 2 dashes on there, that length is the same as that length, which is they're all the same lengths. But this triangle here is an isosceles triangle, right? Meaning these two base angles are the same. These two base angles are the same as each other. All right? Useful stuff to know. Circle theorem number 5. Opposite angles in cyclic quadrilaterals, or cyclic quadrilaterals, depends how you pronounce it, equal 180 degrees. So if this is A and this is B, right, A plus B equals 180 degrees. All right, useful to know. This one, if that's C and that's D, then C plus D equals 180 degrees. All right, useful stuff again. And then angle at the center is double the angle at the circumference for number 6. That means that this angle here, all right, is double this angle here. This angle here is half of whatever this angle here is, okay? Whatever way you look at it. You've got to be careful with this theorem though, because I'll just draw a little sketch of one in here. Terrible circle, I know. But if you've got one that looked like this, if I went from there to there like that, that looks a little bit like the bow theorem, all right? And it isn't the bow theorem because it's not all points touching the circumference. So this point here, all right, this angle here is actually half of this angle here. All right, that angle there is double that angle there. I know my sketch doesn't make it look like that, but that's what that circle theorem is. It's this one here, right? So that could look like this. Be wary of that in your exam papers. I haven't got an example here for you, but I have drawn your attention to it. All right. Now, question number 1 asks us to calculate the size of angle ADC. Give reasons for the answer, as ever. So ADC is this one, right? So there's 2 theorems that come into play here, and it is this one and this one, Theorem 5 and Theorem 6. So what we know is that this angle CBA is opposite this angle ADC, right? And those two would add up to 180. So it's a cyclic quadrilaterals. But what we need is to get that one first. We need CBA or ABC. It's nice to call it ABC, isn't it? So angle ABC is equal to half of 168. So if we take 168 and divide it by 2, we'll get what that angle is. 84 degrees. It's always useful to label it on the diagram as well. So 84 degrees is what that one is. And the reason is angle at the center is 2 times or double the angle at the circumference. Okay, write the whole words, I didn't. Then we're going to use the other angle facts there that I've mentioned. So angle ADC equals 180 minus 84, so 96 degrees. Could use a calculator if you want, but 96 degrees is what that one's going to be. And that is because opposite angles in cyclic quadrilaterals equal 180 degrees. Now, a lot of people get this mixed up with them being the same. I'm not sure why. But yeah, opposite angles in cyclic quadrilaterals equal 180 degrees. And we've got our answer. There it is. Okay, so ADC equals 96. All right. Now, in question number 2, we've got to prove that ROS equals 2x and give reasons for each stage of your working. So ROS is this angle here. This is a radius, this is a radius, so they are the same length as each other, so they are the radii of the triangle, okay? we've got a tangent that meets a radius at 90 degrees. All right, and a circle theorem that I introduced you to in the last video, I believe. Yes, it was circle theorem number 3. So what you have to do here is form some expressions with these proof questions. Form some expressions because we've got that is x, right? So angle OSR. So let's write down angle OSR equals 90 degrees minus this x. 90 minus x. And the reason it's 90 minus x is because a tangent meets a radius at 90. Okay, then we can say that angle ORS, so angle ORS equals 90 minus x as well. Okay, and that's because of an isosceles triangle. Fact, all right? These two base angles will be the same. Okay, now this angle, this angle, this angle, all three will add up to 180. Okay, and then we're going to take away these two angles to give us this missing angle. All right, so we're going to put these in some brackets because they are two terms now that have been collected together to make an expression. So we've got to put them in brackets to make them terms. And we're going to say that S, or ROS, that's what they've called it, ROS, angle ROS, equals 180 degrees minus, and then 90 minus x, whatever that angle would work out to be, minus that 90 minus x again. Okay, now 180 minus 90 plus x is what that will turn into, because you've got a negative on the outside of the bracket. If you go back all the way back to multiplying out brackets videos, that's you'll understand what I'm talking about there. So 180 minus 90 plus x minus 90 plus x, all right, is going to leave us with 180 take away 90 take away 90 is nothing, all right, and then we've just got 2x left. So ROS equals 2x, and we found what they wanted us to find. So therefore, ROS equals 2x. Okay? Tricky question, that one. Definitely a tricky question, but it does revolve around those two circle theorems there. Circle theorem number 3 from the last video, and circle theorem number 4 from this one. That's not necessarily technically a circle theorem, but never mind. I like it. Now, number 3. In this video, final one here, work out the value of x and y. On the face of it, seems pretty simple, but x plus y plus 70, all right, there we go. Those two, those are the opposite angles in a cyclic quadrilateral, and it's a cyclic quadrilateral because all 4 points of the quadrilateral inside the circle touch the circumference, okay? If it didn't, then it wouldn't be a cyclic quadrilateral. So these two angles add up to 180, so we could write an expression there. So x plus y plus 70 equals 180. Okay, there's one equation that I've written. We've also got x and y in this equation here that we can write. So if you can write two equations, you've got simultaneous equations because they've both got the same letter in them. So they're the same value. Yeah, you know what I'm talking about. It's simultaneous equations. So this one, x plus 2y plus 40 equals 180 as well. Right, now there's various different ways you can solve simultaneous equations, but I'm going to do that. Get all the numbers on one side, get the x's and y's on the other. All right, so if we take away the 70 there, we're going to get 110. So x plus y equals 110 degrees. And then take away the 40 there, that's going to be x plus 2y equals 140. Then we solve these simultaneous equations. So that's equation 1, that's equation 2. These are the things that are the same. They're both positive. So we're going to take away, take away, take away. And if you need to get a better understanding of this, then watch the simultaneous equations video solving them. 2y minus 1y, I'm going backwards with it. I'm taking away equation 1 from equation 2. So 2y take away 1y is going to be 1y. And then 140 take away 110 is 30. So we know y is 30 degrees, okay? And then we substitute that back in. So sub into equation 1, something plus 30 equals 110. So x plus 30 equals 110. Take away the 30, that gives us 80, right? X therefore equals 80 degrees, all right? So relatively quick simultaneous equation to solve. not the hardest one in the world, but it's knowing that you have to set that up from the circle theorem in the first place. Check that it works in the other one. So 80 plus 2 lots of 30. Check. I'll just write down the check. 80 degrees plus 2 times 30, which is 60, equals 140. And that does work out to be the case. So x equals 80 degrees and y is 30 degrees. All right, in all certainty, we're all good. And you can always chuck it back in there and see if they both equal 180 degrees as well if you want to. So that's it for this video. The next one is the last one in the circle theorems, and in fact the last one in the whole series of geometry stuff, angles and measures. So I hope you've enjoyed this one. Stick with it for the next one. Keep practicing. Be lovely to one another. Look after yourselves. Take care of your mums, your nans, your dads, your granddads, your brothers and your sisters, and your cousins and your friends and your family that I haven't mentioned. Take care of yourselves. Bye bye. Take care. Peace.